All right, so we left off kind of, excuse me. We've been talking about kind of the normal distribution, how we convert different values into z-scores, look up the probabilities, talk about the inverse transformation last class. Kind of showed you how to do a little bit of an Excel. Excel assignments, I usually have my GA help me grade them. So those last ones should all be graded with the exception of a few. Usually they're ones that are a little bit, if he has questions, I then kind of go back through them. So after this afternoon, every assignment kind of should be up to date on grading. We've got all the iClicker scores kind of uploaded up to date. I've noticed there might be a few of you, 2 or 3, either aren't registered correct, or maybe you're not showing up to class hardly at all. But if you're seeing a lot of zeros in there for your iClickers, I would take a look at it. So like I said, it looks like there's 2 or 3 that maybe someone doesn't have their iClicker registered correctly. So if that is the case, please reach out to me so we can get that settled. I just noticed that the other day. Other than that, any questions before we jump into material today? Okay. It's like a Friday after fall break. So we are going to go a little bit different today, talking about, we're not really going to employ any computation. This is more of thinking about how we're using the statistics that we're coming up with, what the eventual goal is. So trying to paint a little more of the big picture here as we kind of progress through stuff. So the normal distribution is interesting, but we're really trying to understand more about it so that we can build things that are kind of use the normal distribution and are way more kind of useful and valuable to us. Right? So with the idea of this normal distribution, right? We've really been talking about some variable. We're looking at the population data, right? The population data is normally distributed. Okay. We've used in equations before. The size of that population we'll call capital N, and then we'll take a sample that's going to be something smaller, size lowercase n. So using this sample, that's the only data we have to calculate things like the mean. So we're going to have to take that sample we see from the mean and then use that as though it's kind of reflective of what the population's mean is. Now, how close is that? We'll start talking about things probably next week. How we determine, is that sample mean a good indicator of where the population mean is? We can actually make statements about how the representation it would be. But for now, that's what we're trying to do. And take this sample and use it to calculate statistics to make inferences about the population. So we can do this with and without replacement, right? So this is the idea that I'm taking a completely random sample. Like I put everyone's name into a hat in this class. I draw a name out. Maybe I'm recording something like your age, right? That age down. With replacement would be if I put that name back in a hat, shuffled up, draw another name out, write that person's age down. Put them back in a hat, shuffled up, draw another one. Without replacement would be once I draw the name, I set it aside. It can't be drawn again. Right? So especially in a small group, why might doing something with replacement not be a good idea? Let's say I wanted a sample of size 10. I take only the people in the room today, and I draw 10 names with replacement. What could happen? Why might it skew the data?
If you have one person, or like if you have like 2 people in the class that are significantly older,
so you're right. I could have a bias just built in that if I have a small sample, if I get one of these outliers, it's really going to affect my sample. Right? That's for sure the case. I had something else in mind. That's definitely something we want to work with. If I'm doing it with replacement versus without, what's something that could happen? So I draw a name, and give it to you, write your age down, put it back in. What could happen when I go to draw it out again? I could get the same exact person. So with replacement, I could end up with a sample where one person has a greater weight than everybody else, right? They would count as 2 observations as opposed to 1. So usually without replacement is better. I say it's better here. That's probably a subjective statement. I know there's some situations that would be more applicable in other fields where with replacement it could make sense. But for the majority of things that we would want to do, especially in the realm of like applied statistics, with replacement doesn't make a lot of sense for us. Right? We only want to make sure each person has equal amount of weight in our sample. Okay, so we only want them to be able to be drawn one time. And I say people, this could be companies, this could be universities, whatever we're looking at. So once we'll kind of skip this because we don't have infinite and finite populations. We often don't deal with infinite populations. We're never going to do anything with them in this class. And so for us, we're just going to kind of worry about finite populations. So we'll skip this for today. Might revisit it next week. So the next thing that we're going to make sure, okay, I randomly sample, right? But maybe I'm still worried that I end up with a sample, right, where I might have some outliers, right? But one way I could get around that is just start taking larger samples, right? Even if I get someone who's extremely older or younger in a sample of 1,000 people, that kind of gets washed out by everybody else. But what if I'm interested in something like the average age of the United States, and I only sample from this way? Well, I know that you on average are younger, right? And so I know my sample wouldn't have demographics that kind of match up with the population as a whole. So I'll give you a couple other examples. So let's think about health expenditures. And we'll keep using this age example first. If I'm interested in the average health expenditure, like how much people are spending on their health care, as well as kind of surgery, everything else. If I end up sampling just you, I know that you're not going to match with the population because older people on average spend more on their health, right? They just have to. Things start breaking down. A little older than you. That's already happened. So one thing we might want to do is make sure our sample has an age distribution that looks like what we know the population is. Okay? So we might want to do this stratified random sampling, where we'll break the population up into subgroups that we know there's no overlap. So what I might do is say, okay, I want a sample of size 100. So what I'm going to do is I'm going to randomly sample 10 people between the ages of 10 and 20, 10 people between the ages of 20 and 30, 10 people between the ages of 30 and 40. Can I continue to do that in these? And using the cutoffs there, I would have to include the equality only on one of them. But the idea would be I would have 10 age categories and then randomly select 10 people from each one, then throw them all together to get my full 100-person sample. That way I know my sample was taken randomly, but it guarantees that I have kind of an equal representation of every age group so that my sample has an age distribution that looks more like the United States. The other example I'll use, it's a little bit muddy. So we have these non-overlapping groups. We randomly sample from each one of them. We call them stratum, right? These like age categories in my example. And we'll then throw them all back together. The other, I think this is a kind of easy way to think about it, but on any given moment, right, in the United States or any country really, it skews a little bit one way or the other, depending on what country we're looking at. But for the most part, most countries, if we look at kind of the percent of the population that's male and female, it's about a 50-50 split, right? A little bit, we're not completely talking 50-50, but it's close, right? So if I take a sample and I'm interested in something like the average height in the US, but I end up with a sample that has 70 males, 30 females, what do I know it's going to be true about my sample mean relative to the population? So if height, right, tends to be greater in one group, we kind of looked at some of those visuals where the average male height is a little bit shifted to the right of female height. And I end up with a sample that has 70 males, 30 females. What's going to be true about my sample mean compared to what the population is? It's going to be a little bit, I think someone said it, higher, right? So what I want to make sure is if I have a variable, height, that I know is impacted by a certain characteristic, I want to make sure that characteristic in my sample matches that of the population. So what I might do there is break my population up, randomly sample 50 females, randomly sample 50 males, throw those two random samples together. Now I have this random sample of size 100 where I know the gender breakdown looks similar to the gender breakdown in the population. Because if it doesn't, right, my sample mean is definitely going to be off, right? And that's kind of with this assumption that we're usually about a 50-50 split, right, male, female. So I think that's an easy one because like we can kind of think about there's fewer groups as opposed to like all these age categories. But quite often we do break this down by kind of age and a lot of times income. A lot of times we want to make sure our sample has an income distribution that looks similar to the population. Because almost every variable, I shouldn't say every variable, a large majority of variables for individuals will be influenced by what their income is. or what their income status or socioeconomic status is. So a lot of the times we'll kind of do this stratified random sampling like income as well. Questions on? We then have cluster random sampling. It's really the same exact idea, but instead of these non-overlapping groups, we're going to just have small subpopulations that we kind of randomly sample from. So this might be something like I have this large corporation, and it's easy for me to randomly sample in the 5 cities I'm located in, right? Each city is kind of a subpopulation or is a small scale version of the United States as a whole. Right? And it might vary a little bit because urban versus rural, but for the sake of this idea, we could even think about maybe not cities, but maybe we're looking at 5 individual states, right? So I randomly sample 10 people from each state, throw those together, get my full random sample of size 50, but I know that each one of those states would then be equally represented. Right? So a lot of times these clustering, it's the same idea. So right, we sample from each cluster and then throw them all together. Just same thing with stratified. It's just that we're not doing it based off of a characteristic. Usually it's based off some geographical area. A lot of times we see this applied, and I think I have a slide here. Yeah. So a lot of times what we would do is if we're looking at polling data, like political polling data, they might want to make sure that they have every state represented in their sample. So they might do something like randomly sample 10 people from each state and then throw them all together with their full sample. Now that probably wouldn't be quite correct. If I was doing political polling data, I'd probably want to do a combination of like cluster and stratified. So right, not only would I want to break it up by state, but I probably wouldn't want an equal number of people from each state. I probably want to do something like randomly sample 50 people from California, 2 people from Delaware, 10 people from Indiana, right? I would want to try to make it so that the proportion of people in my sample from each state match the proportion of people that live in each state in the entire population, right? And that would really be the correct way to do this if I'm trying to do political polling, because we know that each state, right, has a lot more votes than, or some states have a lot more votes than others, right? So we want to make sure our sample would reflect that. Does this make any questions on this? So these are just some of the early strategies. Now, I probably won't really hammer on these a whole lot moving forward, but the whole goal that we have in mind here is we want to take a random sample, but there are some ways we can ensure that that sample is going to be reflective of the population, right? And there's some things I can do that maybe make that not the case. So, we usually can't take a census, so we're kind of stuck with this sample data. So what are some other pitfalls that we want to be aware of? So I'm going to use an example, and I'm not a history buff, so I will try to break this down as easy as possible, because I know I didn't know about this story ahead of time. So in 1936, FDR ended up winning the presidential election, but he ran against this guy named Al Landon, which, in fact, I never heard his name in history class or anything like that, but right, he obviously lost. Right, FDR won the presidency, but prior to the election, there was this like little magazine. My grandma used to get this still when I was a kid. It was called the Literary Digest. And they did this poll where they sent out 10 million survey cards, right? So they wanted to try to predict the election, kind of using these this poll, right, before it even occurred, right? And they were going to put it in the magazine, and they were made really smart and all this stuff, right? So 10 million seems like a lot of people. But obviously, people have to respond to that survey. So they only got 2.5 million people to respond, but still, right? I mean, first of all, I don't know what other courses you've taken. You ever take like an upper level course where you talk about survey design or expectations? 25% response rate is great. Like if you could, that's why we get those emails where they're trying to like give you a gift card so that you fill out some sort of the chance at winning a gift card. This is essentially right because it's hard to get this high percent of people to respond to an email or a mail. So they got all this back and they think this is great. We're able to predict the election. They predict a 57% popular vote landslide, 370 electoral vote to 161 win. But they predicted that Alpha Landon was going to win. So they know now, looking back, they clearly got it wrong, right? In fact, they got it really wrong. They predicted a landslide in the opposite direction of the landslide that occurred. Right? 500, I don't know history well enough to know, but I've got to imagine winning 523 electoral votes, this has to be one of the highest electoral votes in kind of any presidency. Right? So how did they get it so wrong, right? I mean, obviously, they make math errors, right? Or they're using the wrong variance equations. Obviously not. There's some deeper issues behind what they did. Okay? So let's think about two possible biases that might exist. The first would be, what if they only sent these mailers out to only mainly registered Republicans? Well, then if Outland was the Republican candidate, FDR was the Democratic candidate. So if I only sent my mailers out to Republicans, well, then my sample is definitely going to be skewed towards that candidate. At any given point in time, right, we know that kind of breakdown of the swing, it's like a pendulum, but it's always around 50-50. It kind of swings one way a little bit further some years, swings back the other way a little bit in other years. But if I only send it to one group, right, one political group, I'm definitely not going to have a sample that's very predictive. Right? So what we would call this is the selection bias. If I over-selected kind of registered Republicans here with however I was sending out these mailers. Right? Like if I was getting their name from like the Republican registry or something like that. Right? I could have also done that. I make sure, okay, I don't want to have this selection bias. So I send 5 million to people who have voted Republican in the past, 5 million to people who have voted Democratic in the past. Maybe not registered, but voted them. Well, now I know that I've kind of got an even split. And some of those people may be, changing their vote to the other party. But even if I send 5 million to each side, what if I only get 0 back from Democrats, but 2.5 million back from Republicans? So for whatever reason, there's a non-response from that one group of Democrats. We would call that a non-response bias. And that basically plays out the same way my selection bias would. I still end up with a sample that's only made out of Republican voters. So either one would skew my results in the same direction, but they are operating through different mechanisms. So in this example, there was a team of researchers, I forget exactly what year this was, I want to say it was 15 or 20 years ago, and they were able to go back out and find a bunch of people that voted in the 1936 election. Okay? So when they found all these people, they started to ask them, who did you vote for, right? So they can kind of look back and see, okay, the people that voted for Landon or the people that voted for FDR, right? What was their car and telephone ownership ahead of time, or sorry, back in 1936? And then they also looked at some old data about other political polls and how likely people were to respond to them based off of who they actually voted for. So one of the main problems with the way that the Literary Digest did this is they had built in a couple of these biases, right? So they had a selection bias and a non-response bias. So we'll kind of go over those and look at kind of when they went back and asked these people who actually voted in the 1936 election, can we determine which way this bias was going to kind of push kind of their findings. So the first thing that they did was the way they sent these mailers out is they had like this list of names in a phone book, and then from every kind of state's BMV, or in Michigan they call it Secretary of State, basically whoever's doing the car registrations, they had all these different names that had a car registry zone. So to make sure that it was a real person, they only used names that showed up in both. Sounds like a great idea. We can make sure that people aren't coming with fake names. If they're in both, at least they're using the same thing. So what's the problem if we only had people in our sample, where we're only sending these mailers out to people who own a car and have their own telephone line in 1936? Who's going to be in my sample? Well, people are pretty wealthy, right? I mean, in 1936, to own a car and have your own telephone line is probably not lower on the income district. It also might be more likely that you're a little bit more rural, right? In the sense that back then, having your own telephone line and move out in the country was not as likely. Right? But the main one we're going to focus on is we're definitely over-selecting wealthier individuals. Okay? It tends to be, this is like on average, obviously not true about everyone, but when we look at voting habits of wealthier individuals, they tend to lean a little bit more right. They tend to vote a little bit more Republican. So by only using people who own these two things or had these two things in 1936, we're over-selecting wealthier individuals who we know tend to lean more towards Republican vote. So we have a selection bias built in, right? We over-selected from that right end of the income distribution So our sample isn't going to look like what the population's income distribution is. So when they went back and asked these people who they actually voted for, and then also asked them about whether or not they owned a car or telephone, what they found was for people who owned a car and telephone in 1936, 52.5–53% of them, they went back and kind of were able to find, actually voted for Rand. So the Literary Digest did a pretty good job at predicting what the outcome would have been for individuals who had a car and telephone. However, the interesting thing is if they wouldn't have cross-listed the names and they just would have used any name that showed up in either the phone book or car registrations, notice people who only own a car and people who only own a telephone, about 60% actually voted for FDR. So, you know, even if they wouldn't have cross-listed, they could have fixed their selection bias problem. But they didn't, right? They didn't know this ahead of time. And although it seems like they could have thought that this might happen ahead of time, but they didn't truly know. And they also found that kind of people who own neither, right? So this was definitely been kind of the left side of the income distribution at the time. A very large percent of them ended up voting for those spots, right? So this is why their prediction, when they came up with it, was like 57% in the other direction, ended up only being about 53 based off this sample. Doesn't match up with kind of what the total population ended up voting. Any questions on this? So this is a good example of our selection bias. They also were able to go back and look at the non-response bias. So this was the idea that what if we only Republicans to respond? Now, the non-response bias is a lot harder to fix, right? Because it's not something that we generally have an idea about which way it's going to go ahead of time. I have no idea whether or not Republicans are going to be more likely to respond to this mailer or if Democratic voters will be, right? I don't have any reason to believe their behaviors will be different. Although there's a paper that they wrote about this, they kind of go into a little bit. Now I'll mention their suggestion as to what's going on. But they asked these people who actually voted in 1936, they matched up with these people, the different ownership of cars and telephones. They were able to find another political poll at the time that had who the person voted for in the 1936 election, and then whether or not they responded to this other political poll. So they're calling this, they returned this straw ballot, right? So this is going to be some indicator of how responsive different groups were at the time to actually returning a political poll. It's not perfect. We don't have the actual data on this survey itself, but we had another survey we had data on. So what they found was people who owned a car and telephone, of people that had that ownership and voted for Roosevelt, 17% of them returned this other political poll, this other political survey. While the people that voted for Landon, they returned this other political survey card at 35%. So for whatever reason, right, there's a huge, right, discrepancy in the response rate between people who voted for Landon and people who ended up voting for Roosevelt. So that builds in this non-response bias that, yeah, if I'm setting up these surveys, I'm always going to get almost twice as many back from that Republican candidate as I am from the Democratic candidate. Now, why that's the case, we'll go into that in just a second. But kind of notice, it doesn't matter what they did, even if we look at people who only own the car, only own the telephone, or neither, every single one of those categories, people who voted for Landon were more likely to respond to these other political polls as well. So there appears to be some non-response bias built in that Republicans, for whatever reason, are just more likely to return these political surveys or whatever at the time. I haven't seen anybody look at this recently, but they're a lot more now they're using online tools. I wonder if like this is still the case, right? It'd be interesting to get some data and then come up with that. But one of the main reasons that they give in the article for why this might be the case is if you see a difference in income between Republican and Democratic voters, that Republican voters tend to be a little bit kind of higher income on average, that you just have more time to worry about other things, and that wealthier individuals tend to be a little bit more involved in the politics, right? And so maybe it's that kind of those Republican candidates. The reason why you're getting higher response rates is because those are coming from families or individuals who have higher income. That's their support. They don't have a lot of evidence to support that claim, but that is the idea. And I've seen that kind of floated around in some other political polling data as well. But for whatever reason, Regardless, right? Whatever's causing it, this is going to mess up our sample. We're going to end up with a sample that has overrepresented the Republican Party. So we had both the non-response and the selection bias built into that other example. We'll walk through a couple other examples and talk about some other biases that might exist in one board. So sometimes people lie to you, right? Especially with survey data, and they might do it maliciously, right? Or they might not do it maliciously. So I'll give you a couple of examples. If I ask people, about what their drug use is, right? So if you look at any surveys where they ask people about drug use, what do you think is probably true about the average drug use from those surveys relative to the numbers that we see play out in the world? Much lower, right? Because people are going to lie to you. They don't want to tell you that they're doing something if they think you might have a negative view on it, right? Regardless of whether or not you should, right? So they might lie to you. They might also lie to you because they think they want to give you the answer you want to hear, right? So, look at kind of survey data when doctors ask questions. A lot of times we see results there that people are definitely kind of lying about some of their health. They might non-maliciously lie to you. If you ask somebody what their income was last year, unless they have documents to go back, if you want that value right there during your survey, they're probably made about 50,000. Well, they might have actually made 48,500. So they're doing the best they can with a recall. They're not maliciously lying to you. It's just that they're not actually giving you the exactly true value. Now, that's not their plan, right? But just the nature of a survey, sometimes if you're asking people to recall things, you might be forcing them somewhat to non-maliciously lie to you. Right? They're giving you the best of their memory, but it may be a little bit off. Another kind of big area that we see recently, and I say here, it could just be how you're phrasing the question. Maybe someone misunderstands it. We see this a lot of the times when I'm like, tell me your pain on a scale from 1 to 10. Well, if you think 1 is the most, right? But in fact, 10 is the most, you could actually respond with an answer that's the exact opposite of what you actually are feeling. Right? So misunderstanding the question, but then also the kind of big area of research now is these subjective questions. So I remember in the last lecture, I saw this thing. I can't remember if it was CNN. I think it was CNN that did it, where they asked a question trying to get at the approval rating of Donald Trump at the time. And one way they phrased it, where they led the beginning of the question with, here's these positive things that have been occurring. How do you feel, or are you in favor of how President Trump is running the nation or something? And then the other one, they said, here's all these negative things that are occurring right now. How do you feel about, and you can imagine just phrasing it differently with leading with something that has a positive negative connotation dramatically changed the response. I think it was something like 13 percentage point difference between those two questions that were really asking the same thing. I mean, they literally had the same question at the end. They just framed it with a positive or negative statement at the beginning. So we want to be really concerned with how we're phrasing our questioning, especially when we know that people also might want to please kind of whoever is asking the question. There's some psychology research into that. But we should at least be aware of how we're framing this and try to frame it in the most neutral way possible. Like I said, I think there's whole classes like that in some grad programs where you just talk about survey construction. So we could talk about the perfect way to phrase a question for a long time, but we're not going to dive too deep into it. We just want to kind of be aware. So there's all these biases that exist, right? And here we'll kind of talk about more of them with some other examples. So not a lot of people showing up here today. So we'll kind of give you some easy kind of eye-openers. So we'll use this example. We'll start to talk about some bias that might exist, but really all I want, and I'm not going to look at this if you're concerned with me knowing how healthy you feel today. The extent to which I'll look at it is upload kind of the scores of whoever's here. Right? So there's no right answer here, but how would you rate your health today from 1 to 4? Right? We'll see the number of people we get. So 5, 8, 11, 14, 17, 21, 22. All right, I think we got everybody in here. I think I counted 22, so close it out. So hopefully not too many of you were on at Brothers last night. But, right, let's look at the results here. I forgot it. Click this. Okay, you guys are scaring me. So looked like our average is probably around a 2. Yeah. Okay, exactly, right? So we'll talk about this. I mean, it's funny, but it's also actually important. So if I were to ask you this question, it looked like the average might have been around a 2, so maybe a little bit lower, maybe a little bit higher. But what would be some biases that are built into this question? First of all, if I was to use the mean that I see from you guys as the mean for the population as a whole, what do you think the problem with that might be? You hopefully are a lot healthier than the average person in the US because you are a lot younger than the average person in the US, right? And we know that health declines as we get older, right? So right away, just by me asking you, and then if we try to use that mean, I've built in a huge selection bias, right? I'm way over selecting young people. Okay? Now, what also could be true is I've shut down one of the biases. Which bias did I shut down by making this 900? Hopefully, unless you don't care about your grade at all, right? I shut down the non-response bias by creating incentives. That's exactly what those companies are doing when they offer you a chance to win a gift card, right? They're trying to provide everybody with equal incentives so that everyone is more likely to respond, right? Not a particular group, but everyone. Right? Now, you could argue doing something like a chance to win a gift card doesn't actually equally incentivize everyone, right? Because people who are wealthier probably that doesn't mean as much to them as people who are kind of on the lower end of the distribution. But nonetheless, right, we're at least trying to incentivize people to respond. And here I kind of forced you in a way to respond. So I shut down that non-response bias. What about when it comes to lying, right? Well, I don't know why any of you would want to maliciously lie to me when I'm not even going to look at this data, but maybe you did. I don't know, maybe you statistically, I don't know, whatever. But you probably non-maliciously lied to me, right? Because there's no middle option. So if I feel like a 2.5 today, I forced you to lie, right? Because you can't respond with 2.5. You have to say 2 or 3. So whenever we force things to be discrete like this, right, we don't give people this kind of continuous scale, we're going to innately have built into our data what we call measurement error, right? You were just forced to lie to me. You can't tell me the exact kind of value that you feel in this range. You also might have just misunderstood the question, right? I'm hoping, I think there was someone who put a 4 down. I'm hoping that you thought 4 was the highest and 1 was the lowest, right? Because honestly, when I'm looking at that, I would think the higher number is better. But if you don't look and see, okay, 1 is X and 4 is 4, maybe you give the exact opposite response of how you felt, right? And so I'm getting incorrect data. I'm getting data that has a bias built in because of the subjective nature of how I phrase this question. So all of these things are floating on, right? So it's hard to make sure. We should be concerned with all of these things when we're asking these questions because we don't want all these different biases built into our sample. Okay. Let's see if I forgot any. Oh, the other one I did forget. People non-maliciously lie if you ask them about their health for whatever reason. They've done this like in hospitals where they take different metrics and they ask people how they feel. And people always underreport how healthy they actually are. You always have this negative connotation of yours, which is weird, but it just plays out in all the data they've looked at. So that might be playing a role as well. That might be what we kind of see a little bit, right? I know some of you might not feel great today. If we're really thinking about health on a scale from 1 to 4, I doubt anyone's really going to be down in that 4 range, right? There's probably, if you were in that 4 range, you shouldn't be there, right? So, but this is another thing that's going on. We talked about the discrete option. We talked about the selection and non-response bias component. And then I have another one. Well, I'll ask you this one since we're here. Once again, I'm not looking at the data. I won't do anything with it, so don't worry about it. All right, if I ask you how many alcoholic drinks on average you have each week, we kind of broke it down to these 4 categories. All right, so we'll kind of get this one, and we'll start talking about this, how the bias that might exist in this data. All right, we got 22 of us in here, so we'll close it out. Okay, so what bias might exist in this sample? First of all, let's think about the main 2 we started out talking about. If I shut down the non-response bias in the other one, looks like everyone responded, so looks like I did a good job of shutting down the non-response bias here. But what could, if I ask this question in a slightly different context, where maybe IQ points were associated with it, what's a non-response bias you think might be built into this question? maybe people just don't want to let them know, right? So people that drink a lot are going to be less likely to respond. So if people who drink a lot are less likely to respond, my sample mean is automatically going to be biased to be closer to 0, right? It could also be that if I'm not 21 yet, I don't want you to have this data that I drink more than 12 drinks a week, right? I don't want to admit to that. So in a broader context, I'd be worried about that because it's pushing out the lower age categories, which I know tend to drink more than the population as a whole. And so I'd be skewing my mean down closer to 0 once again, right? So this non-response bias really could be playing a role in a question like this. Like I mentioned earlier, if you ask people about their drug use, right? Same kind of mechanism is existing there. What's my selection bias though that could exist? You are younger. What do you think is probably true about college drinking? I mean, this is like a played out trope, but college age drinking habits are quite a bit different than the U.S. population as a whole. I can tell you, being not too distant, removed from that, I don't drink near like I used to when I was in college, right? So we know that this sample would not match up with the population as a whole at all, right? Because we would have this really, really young kind of sample versus, an age distribution that is more even kind of in the United States population. So we got our selection and our non-response bias. People might just maliciously lie to me, and really it's hard to predict these sometimes. It's hard to predict which way the bias would go. Because some people might maliciously tell me, I don't drink near as much as I do, right? But other people might want to be the one guy at the party who wants to let me know that I drink, 30 plus a day or whatever, they want to brag about, okay? So I don't really always know which way these biases will go, but I know they exist. I know I should be aware of them, right? The other one would be that I maybe non-maliciously lie. I'm not sitting down and recording exactly how many drinks I have every week, and so I'm choosing the number from the best I can from recall. But right, I don't know if I'm around 12 or 11. I don't know which category I'm going to choose there. I might accidentally kind of give you a slightly under or over reported value. This one I don't think has too many subjective, like there's no real subjective term bias here. I don't know why you would misunderstand the question here, but I don't know, maybe you come up with one if we thought hard enough. So those are kind of some of all the biases in the sample. I think we kind of got all of them. We'll talk about one more, and this came from a paper, and I'll try to get this posted on Canvas this afternoon in case anyone's interested in it. I thought I knew where it was when I was looking for it this morning and couldn't find the file, but I know I can find it on Google later. So they basically went through and talked about the different bias that might exist in political polls in the 2016 election. Right? So this is kind of interesting. And it played out a little bit more in the 2020 election, but some of these companies got better. Right? So in 2016, almost every poll predicted the election incorrectly. Right? I think there was like one poll that predicted Trump was going to win out of who knows how many hundreds there are. So how did they get it so wrong? Right? Like what biases were built in to their sample data, right, that didn't reflect the attitudes of the population. So there could have been some selection bias. It looks like there might have been because a lot of these companies were able to fix it in 2020, but a lot of these companies are centered in large kind of urban areas, right, kind of big cities. And so it's easier for them to get people into their sample from these cities. It may just more, less likely they can get outreach into these other areas. And so maybe we have kind of built in like this urban, right, or inner, or urban, or like we have people from larger cities overrepresented. People from larger cities tend to lean a little bit more left, right? So that's going to kind of bias our results, right? Now, I don't buy this one too much, only because in 2016, it's not like we didn't have the internet to use, and they could have done polling through that and really done outreach to almost every kind of size city. But that was one kind of thing that the article mentions. The big one was going to be our non-response bias, right? So in 2016, I don't think I'm going out on a limb here saying Donald Trump is somewhat of a divisive character, right? There may have been individuals who just didn't respond if they knew they were going to vote for Trump. They didn't want whoever was asking who they were going to vote for to know. So maybe people who were going to vote for Clinton at the time were more likely to respond to these political polls. right? So we had kind of this non-response bias built in that was also going to make it look like Hillary Clinton was going to get a larger percent of the vote potentially than Donald. So, you know, the way the article phrases is maybe they just kept quiet, right? They just didn't respond at all. And even if they did respond, so even if it wasn't the non-response bias that was causing us to get these incorrect predictions, you can kind of think about non-malicious lying or unintended lying. Maybe there's a lot of people who are switching back and forth. They weren't sure who they're going to vote for. They hate politics in general. They don't trust either side. And so when they were asked a question, they gave the name that they thought they would vote for at the time, but by the time of the election, they switched, they changed their mind, right? So maybe I had some unintended lying here. But then the main one that they focused on was this malicious lying. So when I say malicious, we just mean you intended to lie, right? And so the main one here, and they were able to gather some data where they actually got some people who voted for Trump and actually had some qualitative data about why, maybe they didn't say they were going to vote for Trump in some of these political polls. And they call them these shy Trumpers, which is that they knew they were going to vote for Trump, but when asked, right, they felt like there was some social cost. A lot of these are done over the phone. A lot of these are done, sometimes people going door to door. And so if you have this personal component and you think this other person might judge you for whatever your response is, right? In this case, it's Trump, but it could have been for the other candidate as well, right? If the Republican organization, the county shows up at my door asking who I'm going to vote for, maybe I have some feeling of, well, I know what they want to hear, so I'll just tell them I'm voting for their candidate, right? And that's what this article really goes into with these shy Trumpers, that they knew they were going to vote for Trump ahead of time, but all these political polls, they didn't want to give that as a response because they were kind of concerned with the social cost that might exist. So, this really makes a good point when we do this political polling. We want to try to strip kind of any emotions from it all, right? All we care about is getting an accurate response from the person we're asking the question. So to me, this suggests that why are we still doing things, doing phone banks? Why are we still having people call up with this personal touch where it can maybe skew how the person's going to respond to you, right? We've got the internet. We've got these completely nameless, faceless, entities or we can ask questions on and people can respond without really feeling any type of kind of social cost or benefit to whatever the response is going to be. And especially in political polling data, this kind of plays a role. So kind of interesting, we could take real world examples and think about what biases might exist when we're looking at the sample data. And I thought this was kind of an interesting, not too far off in the distant past, and also kind of make sure that moving forward, if we're doing political polls for the next election, we've got candidates where we have a similar thing going on. We might want to take this into consideration when looking at the actual prediction. Okay. So where we at? Kind of set us up for next week. So I think we'll kind of revisit this on Monday, but I just want to give the idea behind what we're setting up. So we took this sample. We know we have all these biases that we have to be concerned with, right? We want to be aware of. So the next thing that we're going to start thinking about is, I had some original variable I was sampling from, right? Maybe I'm interested in the average income in the US, so I take a sample of size 100 people. And maybe I use some random, stratified random sampling, and maybe I make sure I shut down my non-response and selection biases. But I'm going to be able to have this sample of 100 and then calculate a sample mean. So I randomly sample 100 people, collect their incomes, calculate the average income from that sample. I write that number down. I go out and get another random 100 people, calculate the sample mean, write that number down. Go out and get another 100 people, calculate the sample mean from them, write that number down. If I were you, you can imagine eventually I can have like an Excel file where I've got 1,000 different samples and the sample mean of every single sample. So I've now got 1,000 sample means. Well, what can I do? I can create a histogram, right? To kind of look at what the distribution of those sample means are. I've got 1,000 sample means. I can simply create a histogram like we've done with the data in the past to get an idea about what the distribution of these sample means looks like. So what's going to end up being true, as long as we have over 30 people, our sample means will always be normally distributed. So today you're just going to have to take me at my word. I'll have to prove this to you next week. But if we have over 30 people in the sample, our sample means would follow a normal distribution. And not only that, but if I had those 1,000 sample means and I put equal average in Excel and found the mean of those sample means, so right, the mean of my sample means, it'll end up being exactly whatever the population mean was of that variable I was sampling from. So these things for right now, you just have to take me at my word. Next week, I'll prove to you, I probably won't show you the mathematical proofs, but I'll prove it to you using data. I'll show you how, in Excel, we actually can randomly sample from a list of observations. So I can come up with, I think I did 1,000 different sample means for different variables. So then we can look at what the distribution of those sample means actually looks like with real data. Okay? So you should be able to get through the first third of that Excel assignment, and you should now be able to get through about half of the Connect assignment. Try to chip away at those. Everything else we should cover next week. So you'll have everything you need to kind of finish them, but it'd be easier to get some of the questions out of the way now. Okay? All right, you guys have a good weekend. I will see you on Monday.